alaikum wa rahmatullahi wa barakatuh, guys. So I'm currently at school. So this is the second time I've ever recorded at my school. And yeah, I just prepared the prayer mat. So I know the younger kids could like come here to pray at like any time. So if they do, I'm gonna have to stop recording the video. But in the meantime, I'm gonna try to get some capacitance work done because we have a test today and I literally did not know until this morning. So I'm gonna try. Which one is it? This one. Oh, this does not look fun. But it'll definitely teach me a lot. So yeah. Right. Let's go ahead with that then. So, yeah, I need to drink some water because look, this is from many hours ago and it's still full, which means I've been drinking it. I think like on average I've been drinking like 500 milliliters every day, which is absolutely insane. That you should be drinking like 2 liters a day, so that's why I have like no energy, bro. Anyways. Do I even have my calculator on me? Yes, I do. Okay. I'm very tired and sad. I don't know why. So I'm gonna eat some food and hopefully that'll make me feel better. So, firstly, there are a couple things I don't understand. For example, oh my days. I'm going to do a capacitance test. And what is capacitance? Capacitance is to do with capacitors. And what is a capacitor, you ask? A capacitor is an electronic device that stores charge. But why do you need to store charge? Maybe you need to release like energy very quickly and you need to release a lot of it, but your power supply doesn't have that much energy, so a capacitor will store it up and then release it like as a single pulse and then release a lot of energy very quickly. But the thing I don't understand are the charging and discharging curves. Like, because charge, for these curves, charge, voltage, and current can be like swapped around. So, for example, I need to show you like, for this one, it shows decay of charge, and then you can swap Q with V or I, and that's the thing that's like very confusing. So I'm gonna look at Save My Exams, see if they have anything that can help me. It's cold, by the way. Okay, so polar molecules. A dielectric is made up of many polar molecules. A dielectric is the insulative material between the two charge plates, which is essentially what makes up capacitor. Capacitor is two charge plates. Well, they're not charged to begin with. They're two metal plates separated by a dielectric. And then when you put a current through there, then the charges will build up and then the polar molecules, which are inside the dielectric, will start to align to the plates. So the negative ends of the polar molecules are attracted to the positive plate, and then the positive ends are attracted to the negative plate, like here. Very nice. Very nice. Okay, that was it. So I guess I just have to get started on the work. How much time is there? I have like 25 minutes, give or take. Okay, let's get started then. So the capacitance of a capacitor is given by the equation C equals Q over V, and then C is capacitance, which is measured in farads, and then Q is charge, which is measured in coulombs. V is voltage, which is measured in volts. What does it mean if a capacitor has a capacitance of 370 microfarads? It means, well, so it's Q over V, so it's C and then V minus 1. Those are the units, in like SI units, whatever. And then, what is CV? Coulombs per volt. So it means, I'm not sure what capacitance is. What is capacitance exactly? I don't think I wrote it down in my book. Capacitance, A-level physics. One coulomb of charge stored per volt of potential difference. Is the window open? No, it isn't. Why is it so cold then? Maybe that door is open. Coulomb, capacitance. What was I even searching? I can't remember. Yeah. What's the difference between electronic versus electrical? Electrical refers to anything that uses electricity, while electronic uses electric currents. Okay. Right. Oh, I'm gonna check if that door's open because it's freezing. It's absolutely freezing. Dude, I think I'm unwell too, you know? I think that's why I feel so sad and fatigued and whatever. I'm unwell because I slept 4 hours the day before yesterday, and then yesterday I slept just over 9 hours, I think. Or 9 to 10 hours. Yeah, because I was so unwell. Anyways. If a capacitor has a capacitance of 370 microfarads, it means 370 microcoulombs per volt. Whatever that means. What does that actually mean there? Stored 370. Oh no, I need to charge my phone. 370 microcoulombs of charge is stored per volt, whatever that means. Okay, so now draw a second line on this graph to represent a capacitor of high capacitance. So capacitance is Q over V, so if we want a high capacitance, we just need a high gradient. I should use a ruler for that. And it's a straight line, because constant gradient. What does the gradient represent? Capacitance. How is the energy stored by the capacitor calculated from this graph? So I'm going to get the formula book right now. Capacitance, or energy stored, is a half QV, which is the same, because this is QV, so multiply them together, you get like a triangle, if you divide by 2, and that gives you the area under the graph, or under the line. And that gives you the energy stored by the capacitor. So E equals half QV. Second line is to high capacitance. So instead this is V over Q, which means this is 1 over C. If we want high capacitance, we want a lower... Wait, let me just write this down. So 1 over C equals V over Q. Which means if we want to increase C, we need to increase Q, or like decrease VQ. If we want to decrease VQ, we draw a shallower line. That's something I need to remember, because if they do the graph the other way around, then it's 1 over C, not just C on its own. Okay, so how is the energy stored by the capacitor calculated from this graph? So before it was E equals half QV, but now they're the other way around. But if you multiply them, then it should be the same. So I think it's still E equals half QV. So what does the gradient of this graph represent? 1 over capacitance. So how can I have a shallow gradient, but that means it's a higher capacitance? I think, so for example, if we were to calculate the energy stored by this capacitor, and we did it like that, on this graph, it would be the same area, because they have the same energy stored, because they have the same capacitance. But since you flipped it around, obviously the height is going to be the base, and the base is going to be the height. And that's the difference if you swap the independent and dependent variable on the x and y axes. So energy stored by a charged capacitor can also be calculated by using one of these 3 equations. Yes, I mentioned that. E is energy stored in joules. Units are joules, and that's OULES. Quantity, this is charge, V is voltage, and C is capacitance. And then Q is coulombs, so I spelled that wrong, OULOMS, MBS. V is voltage, and C is farads. Use this diagram to describe how each plate of a capacitor becomes charged. So, a capacitor has 2 plates. Voltage goes from the positive terminal to the, well, electrons travel from the negative to the positive, but conventional current, which is the way that current flows, goes from positive to the negative terminal. Which means, due to the voltage across the power supply, results in a current across the capacitor, or a voltage. Wait, I'm not sure which one to put. Until it becomes charged. To be honest, I don't really know. Which builds up charge on the plates. I think I wrote this down earlier, so I need to check my answer. Charge on plates until all the polar molecules are aligned. When the plates are charged, an electric field is created. Okay, let me check my answer that I wrote in my book, because that probably has a better definition than the one I gave. Charge difference creates an electric field. Pulse producing circuits, yeah. A capacitor is a passive electronic device which stores charge. Consists of two or more conducting plates separated by a dielectric. Charge stored per unit potential difference. Oh, I'm tired. I'm really tired. I think I might go get more food. Electrons flow from negative terminal, yeah, to the positive one. They spread out on one of the plates. As electrons arrive, they repel electrons on the opposite side, causing electrons to flow back to the positive terminal. This leaves one plate with negative charge, the other one with an equal but opposite charge. Okay, I need to rewrite my answer then. But I'm not sure if it's entirely correct, so I'm going to check with the... I hope she put them on screen. Otherwise, how am I supposed to do these questions, man? I can actually get food in like a few minutes, so I'll do that in like 10 minutes or so. Oh wait, I might just do that now. Yeah, I'll do that soon. I'll go get food and then I'll be back. But first I want to see if she actually put this on Teams roll. I just heard a plane sound. Biology paper does have one question from homeostasis on it. Please be aware. Okay. Computer science. Haha. Anyways. I forgot what I was doing. I wanted to go on to year 13 physics. Okay. It should be in capacitors. Yeah. Exam questions, answers. Nope, those are not the answers I'm looking for. Oh well, I'll find out later. I'm gonna get food and then I'll be back. See ya! Hey guys, I am back. Look, this is the food I got. So I need to find where the capacitors exam questions answers are. Because I can't find them. So I'm not sure what I meant to do exactly. I could do these questions. Yeah. Oh. Let me see if it's on the physics school directory. Student resources. Also, I'm gonna eat my food in the meantime. Look, I have a very juicy watermelon. Look. This is not a mukbang, guys. I don't know why I'm eating in front of the camera. Maybe that's disrespectful, to be honest. Science, physics, right? Okay, I'll eat off camera then. Okay, let's see, capacitance. I can't find it, man. Okay, 6-1. Capacitance. Nah, bro, it's not here. That's so sad. There's no point in doing these questions if I can't even mark them and check if they're correct, bro. So, okay. I'm going to do different questions then, because I can't mark these ones, which means it's not going to be useful to me. Although, yeah, there's no point then. No point. So I'll do the questions that she sent in our previous lesson, because she gave us a mark scheme to those. Oh, don't. Oh my goodness. Why is this so messy? Okay. Like, I'm very organized with sticking everything inside my book, but if they're stapled, then it causes a problem anyway, no matter whether you stick them in or not. Okay. This question. Right, let's do this. Okay. So, why movement of the diaphragm causes a potential difference across R? Why does it do that? Let's see. So, exponential shape, value, level effect 3V. Why movement of... No movement, no change in chart, no signal. Moving the diagram changes the capacitance. And... Okay. So... So this is talking about a microphone which uses a capacitor with two fixed plates and, well, actually one of them is a diaphragm, so one of the fixed plates moves. So moving the diaphragm changes capacitance. But why is that useful? Why does that cause a potential difference? As C changes, so does V. C is Q over V. I'm so confused. As C changes, Q changes. That's different to what I said before. Q flows through R. I think some students go. Your pay room is 251. I put the pay mats upstairs. 251. Yeah. Jazakallah khair. Anyways, yeah, some younger students just ran into the pay room as if they owned the place. Anyway, okay. Yeah, I don't understand why that is like that. But yeah. But yes. Oh well. I'm gonna eat some food in the meantime. Oh, bro. I'm just say moving the diaphragm changes C, and since C is Q over V, changing C changes Q. Changes V, sorry. And V equals IR, which means the current changes, and therefore I'm really so confused. What is going on? V changes, VC plus IR is constant, hence IR changes and there's a signal. So, I think what's going on here. So we have a 3 volt power supply here, and it's going through a capacitor and also a resistor, but first it's going through the capacitor. Oh, it doesn't actually say, but oh well. It goes through the capacitor, and then the capacitor has a voltage across it of VC, V like subscript C. And then the voltage between this is IR because V equals IR. And then current is not constant because with a capacitor, it's actually insulative material on the inside. And if all the current flows through, there's no voltage. Wait, current always flows through. I'm so confused now. What? I don't understand electricity at all. Like, at all. If only some physics person could, like, help me in this moment, like, right now. So, we know that as the diaphragm moves, the capacitance changes, and therefore the voltage changes across the capacitor. But the overall, because voltage is shared on series circuits, the voltage for both these components has to add up to 3, because there's no other components across the circuit. So here, so if this is decreasing, if the voltage decreases here, then it has to increase on the resistor, which means as the voltage across the capacitor changes, the voltage across the resistor has to change to ensure that 3 volts is being supplied to both of those components in total. Well, that's strange. Okay. Then the next question. Any sixth one, capacitor is charged. Energy stored in C goes to lamp. Heat and light in lamp. Okay. Cap charged. Energy stored goes to lamps. Oh yeah, I forgot. I need to charge my phone once again. And then E equals a half CV squared. What? Heat and light in lamp. Heat. Assalamu alaikum wa rahmatullahi wa barakatuh. T equals RC. What is R in for the time constant? R is like resistance, right? What is R? I can't remember. I really can't remember. Ah, thank you for it. And yes, the student came to pray in the prayer room, so that's why I was quiet. But now they've gone now, so. Time constant, time taken for the charge to fall to 37% of its value. Bro, where do you get R from though? Oh, R is literally resistance. Okay. So, here we have one lamp, so resistance is going to be equal to one lamp. And here we have two lamps, so the resistance for a series circuit is added up, and then for parallel it's 1 over R plus 1 over R. So it's 1 over 2R plus 1 over 2R, which is 2 over 2R, equals 1 over total R. So 1 over R equals 1 over total R, so resistance stays the same. Okay, so even though we have 4 lamps here, and then we have 1 lamp here, the resistance is the same on both circuits, because of the way they're laid out. So R is the same, which means, because the capacitance is also the same, T equals RC. I just changed the document. T equals RC. R is the same for both circuits. Same charge through each lamp. So the battery can have a higher voltage but the same charge per lamp. So because the time constant is the same, the flash is bright and dies exponentially. Because you know when you're discharging a circuit, it's an exponential drop. Exponential drop. And then V times 2, which means charge times 2. Oh, so charge is proportional to V, because capacitance is constant. Oh. So V is proportional to Q in this case. And because of that, because we have 2 times Q, and then we have 2 branches here, we're essentially having the same current run through each branch as in that other circuit, which means the current is the same, the resistance is the same. Is it? No, it's not. The total resistance is the same, but not in each branch. What does that actually mean? Oh, same current, so they're the same brightness, and also there's the same voltage too, because it's shared. Okay. Same voltage, same current. Okay, that's that question. And then the third one, W equals QV. Area under graph. Okay. Energy stored by the capacitor is 875 joules, yeah. Use the graph to find the time constant. The time constant is when it drops down to 37% of its original value. So 37% of 5,000 is 1,850. So if we had to draw a line at 1,850, that would get us to 3.5 seconds. And then the total resistance of the circuit, including the paddles and the chest, what does that even mean? Okay. It's 47 ohms. Calculate the capacitance of the capacitor. So capacitance is, we need an equation that relates resistance and time constant, if we even have that somewhere. Capacitance is, is Q over V, but I need another equation. It's a 2 more question. We have energy stored, so E equals a half CV squared. What do we need to find out? We want to find the capacitance. So we have energy stored, we have resistance. We don't have current, do we? How are we supposed to... If it's the same question as before, then you can just work out the gradient of the graph. So if C equals charge Q over V. So in this case, we're doing voltage over charge. So yeah. Assalamu alaikum warahmatullahi wabarakatuh. Okay. Yeah, the Q. So you actually need to swap that around. Assalamu alaikum wa rahmatullahi wa barakatuh.
What's the time?
12:50. Wa alaikum salam wa rahmatullahi wa barakatuh. Assalamu alaikum wa rahmatullahi wa barakatuh.
Do you know why yesterday when we were praying at the end of break, a sixth former came and he said he has to supervise us while praying?
Oh, yesterday was Wednesday, right?
Yeah.
Do you know if it was Kabir, his name?
Yeah, I think.
It was Kabir. Yeah.
Why?
So you know how I'm supervising you guys on Tuesdays and Thursdays? We're trying to get other sixth formers to do the rest of the days
We
too.
don't need supervision. We're very mature, responsible, sensible, and we're more sensible than some year 10s, maybe.
I
Not
agree.
year 11s.
Yes, I agree. You're actually more responsible than most people on my bet.
I can smell the
I'm gonna go over one last question and then I've got to go. Okay, right. So, on one particular setting, the discharge lasts for 2 milliseconds. Calculate the energy left in the capacitor at this point. So, energy is... How are we going to link that to time, though? I don't know. I have so much back pain right now, bro. Oh, man. Whatever. The energy is selected by the... This is... The energy left in the capacitor? I have no idea. And this is 2 more questions. For 2 milliseconds. So at 2 milliseconds, the voltage is around 2,800. Let's say 2,800 volts. Okay. So how much energy is that? So energy is half QV. Do we have Q? I don't think we do. I guess we kind of do. So if we go 2,800 and we read it from here, it's around 0.2 coulombs. So energy equals a half, and then 0. Times 0.2 times how many volts? 2,800. Which is 280 joules. How do I even find out how much energy? Oh, okay. The energy stored is 875. So take away 280. That is around... I can't do maths. 600 joules. Around about that number. Energy leaving capacitor. I got that wrong. Okay, at 2 milliseconds, voltage is 2800. E equals a half CV squared. Okay, I got the correct amount of joules, yeah. Energy leaving capacitor. Energy setting. I'm very confused. Energy delivered is... what? Energy left in the capacitor. Is 600. Shows voltage for capacitor used in a defibrillator. I don't even know which one is the correct answer because this mark scheme is so trash. This mark scheme is so trash. I don't know. Whatever. Whatever, guys. What? So sad. But oh well. Achieved inside the machine electronically. Okay, alright, I'm gonna go into that test pretty unprepared, but what can I do, because I can't do anything else, guys. Alright, I'm gonna have to go now. Wa alaikum salam wa rahmatullahi wa barakatuh. You alright? Hope you enjoyed this video, see you in the next one. See ya!